Okay, good day, class. So today we'll be discussing the last topic for our midterm, clippers and clampers. So I'll start first with clippers. Okay. So clippers class, or another term for that is the diode limiters. These are networks that employ diodes to clip away a portion of an input signal. So basically, if you have an input signal that is sinusoidal, or actually any signal that has a positive and negative cycle, pwede siya naka-square, pwede siya naka-triangle. The idea for clippers are they clip away a portion of an input signal. So actually, one of the basic example is na-discuss natin, which is a half-wave rectifier. No? Di ba sa half-wave, they clip one portion of the signal. It could be positive cycle or negative cycle. Ay yang i-clip depende sa atong pagkabutang sa atong diode. Pero the idea here is it clips the portion pero without distorting the remaining part of the applied waveform. So, ingon diri example na ang half wave rectifier. But we have two general categories for clippers class. We call it series and parallel. Okay? So, kaning series and parallel, they basically refer to the diode which is connected no, with respect to your input. So series siya if they're connected in series ang diode ang input uh, voltage input, and then parallel siya if it is connected in parallel obviously. Okay, so let's start with a series na clipper. So again, the diode is in series with the load, and you're familiar with this, no? This is a half wave rectifier. So we have an input here and then output nato which is a cross-year resistor. So ang diode nato ato lang gyapon i-assume nga ideal siya no for easy visualization or easy analysis of the circuit. So we have here kini nga diode so series nga clipper. Okay? So we're used to sinusoidal inputs, but for example lang natay square input and square wave input. So same lang po siyang idea class. For positive cycles, you can see it will be forward bias. So the equivalent for that will be like this. Naka-input, and then what happens to your diode? It's just a closed circuit, and then you have a resistor. So basically, what happens is your voltage input is just equal to your voltage output. Okay? Ang basahon na niya dira sa imong output will simply be the input voltage. So mao ni imong input. Okay? Mao ni imong input. So sa output nimo basahon na pud niya exactly ang input. So it will just replicate your input. So kung unsa imong input, mao sa imong output during positive cycle. For negative cycle class, mo nimong negative cycle, no? What happens to your diode? It will be reverse bias. So, ang mahitabuan na it will become an open circuit. So, no current is flowing through your resistor. I is 0. So, 0 times your resistance. VO will always be 0 volts during the negative cycle. So, that's why during the negative cycle, ni-clip siya. Ma-0 siya. It's the same thing with your kanang triangular ni mga input, no? Okay? So, same gyapon sa sinusoidal. Imong sinusoid, imong input, ang imong output will be positive ra and then clip sa negatives. Okay, let's go to a series clipper with a DC supply. So, this is what you call class a biased series clipper. You say bias, it means you're introducing a supply voltage. Okay? So, gibutang nato siya dira in series with our diode. No? So, it could be that the positive is na dira sa left side, pwede sa negative, positive. Depende sa mong orientation. And they will have different um, output waveform. But in this case, unsa may output waveform na to? Atong i-analyze class because this won't be simply parehas aning output. Kaya na naman kakaribayan. So there must be something that will change sa imong output. Okay? So itong tanawon. Okay. So, ayang example kay balik class, pero sige lang. Ang example natin diri is 5 volts wherein your negative polarity is on the left side, positive polarity sa imong right side. Okay. So, now, let's imagine sa atong positive cycle. So ato sa muna naon during positive cycle diri sa ta isolate na to analysis diri. During positive cycle class, what happens to your diode? Okay? Duha naman ang mag-affect gud sa imong diode, your 5 volts and your input. Pero there is no problem during positive cycle. Why? Because ang imong 5 volts here, no? It will create or it will make your diode forward bias. Okay? Okay, positive man mo dira, positive sa na. So wala kay problema. So your diode is forward bias with respect to your 5 volts. Your input also class forward bias yapon. Pero ang pinaka-easy ni mga buhaton na is we can try to redraw the circuit so that di kita malibog ba that we should consider mango the total of this voltage, no? So kana siya kung say total ana, will it still be forward bias your diode or not? Okay, so kana man na to ang concern. So during positive cycle, we can redraw our circuit in such that your 5 volts will be here. Ito lang ikuan. Para parallel atong pagtanaw. And then your input will be here. Okay, positive. So wala problema. Your diode is always gonna be forward bias during positive cycle. Okay, and then you have here the resistor. So as you can see, your voltage output class, dili na lang siya dependent sa imong input. But it's also dependent sa imong 5 volts because now your voltage in output will be the sum of your input and your 5 volts. So during positive cycle, VO is always gonna be 5 volts plus your V input, right? That's why tanawa diri sa imong positive cycle na. Kung ato siyang itungod diri sa output class, naunsa siya, di ba nisaka siya og 5 units? Okay? Tanawag, naka-erase, pero sige lang. The zero here, atong itong ibutang na V output for positive cycle is VI plus 5. Okay? So during positive cycle, kung zero ang imong value dira class, kung zero ni, therefore na nakadaan 5 volts. Okay? So that's why kini nga value nga zero diri kung ato siyang i-map diri, iba ang tungod niya kay kani 5 volts. Okay? Tanaw pa na to ang 20 diri class. If input na to kay 20 volts. So, if i-add na to siya 5, that will be 25 na. So, that's why naka 25 volts dira nga peak to positive. So, it's just like shifting your positive cycle nga waveform no, up no, by 5 units. Okay? So, kaning 0 ni mo dire, kana ang tungod ana niya kay kaning 5. Kani mong negative 5 dire, ang tungod ana niya kay di na siya state no. Ang tungod niya na kay 0. Okay, if your input is a negative 5, you add 5, that will be just 0. Okay? And then, sugod na dayon class sa value nga beyond negative 5, say negative 5.1, negative 5.2, until the negative 20, okay, what happens? Mahimo na ni siyang 0. Nga nang mo clip man siya, nga ni ang iyahang idea. During the negative cycle, manggod, you still have the 5 volts nga battery na supply, pero you will have a negative value na sa imong VI, di ba? VI. Okay, this is still your R. And then forgive my drawing kay galisod ko og sulat. Okay, this is still your output. Okay, imong VI class, pag negative 5 na siya, nagnanam ko yung negative dira no, sa taas. If negative 5 na siya, mahimo na siyang 0. Okay, so wala ka problema. You still, the ideal diode still conducts. Pero, pag mahimo na niya siyang negative 6 or negative 5.1, basta kayo more than na siya ani na value. What happens is that this potential here, okay, ang parallel ana or the sum ng duha, mahimo na siyang negative nga value. Okay, kung ako negative 6 there, then this will become negative 1, right? And this negative 1 will reverse bias our diode. Okay? Again, pag mubiyan na siya og 0, musugod na siya ka negative value class, the diode here will become reverse bias. Therefore, mahihimo na ni siyang open circuit here. Okay? So, kung open circuit siya, of course, walay current mo flow sa imong resistor, your voltage output will always become 0. Alright? So, mo nang gikan sa imong -5 pabalik sa imong -5 kani nga portion sa imong negative cycle, zero ang imuhang output. Okay? That's why nisaka ka diri gamay kining pagsaka nimo ani ni-conduct na imong diode ana kay nibalik naman siya -5, -4, -3, -2, -1 and then lastly 0. Okay? So ni-conduct na siya sugod again pagbalik ni -5, -4 and so on. Okay? Ma-positive naman pud ang sum niya diri. So mahimo na po siyang forward bias ang diode. Okay? But the idea remains the same. This is still a clipper circuit. Clipper circuit ya po siya. Clip man siya o portion of the signal. Okay? Pero, specifically, this is your biased series clipper. So, there are different kinds class. Kini siya ang simple series clippers na to. Atong ideal diodes man siya, no? Then, wala siya bias. So, could be like this or it could be like this ang iyang orientation. And these are the output voltage for equivalent nga circuit. We also have, akong giingon ganina, bias series clipper. So there are 4 types. Bali-balihon lang nimo class. Kung i-remain na to the same mga atong diode, atong bias supply no ang gi-add nato is pwede positive ang left, negative ang left. And you will have a different uh, voltage output. Okay, lahi mang waveform for that. Lahi pa namang waveform if gibali nimo imong diode. Okay, mo ni siya ang waveform. And you can try to solve each circuit. Dili na nato i-solve dire, pero this is your guide for the output waveform of your bias series clippers for different kinds of bias series clippers. Okay, so let's go to the parallel. When you say parallel, again, ang diode na siya with respect to your load or respect to your input. Actually, sorry, nag-emphasis ako din na with respect to your input, pero actually, it is with respect to your load. Kay, di man ta pwede kaingon nga completely parallel with siya with your input because of the resistor. Sige, it is parallel with the load. Load ni mo dire, pwede man ni mabutang resistor dire good. O pwede sad mo na ni measure nga output. Alright, so lahi po ang yang tumong ani class. Oh, the idea is remains the same nga mag-clip gyapon siya. Pero what happens is that instead nga atong resistor nga tong fog output karon diode na. Okay? So to say analyze first. During positive cycle in this type of circuit, what happens? Positive niya anode. So this is forward bias. Unsa gani kung forward bias ang imong diode? It will become a closed circuit. Okay? So kung naa kay VI dira, you have a resistor. So what happens to the diode? Mahimo siyang closed circuit. Okay? So what is now your voltage or output voltage? If basahon nimo na i-measure nimo ang voltage class sa imong closed circuit, di ba we read it as 0? Okay, output of a closed circuit is always gonna be 0. So that's why during your positive cycle, though nagkandak ang imuhang diode, tungod kay nag-measure man ta sa output voltage across your diode mismo, it will be 0. So that's why during positive, nag-clip na noon ka dira. Okay, kay basin ba malibog mo nga. Lamang di ba kung nagkandak ang diode kay iyang i-output niya ang input nga signal. Then kung mag-clip siya, meaning ga-open yung diode, it depends. It depends on the orientation. Asa ni mo gibutang imong diode. In this case, parallel man ta. So therefore, ang clip niya nga function is mo-function siya during the time nga magkandak ang imong diode. Okay. During the negative cycle, unsa pa mahitabo? During the negative cycle, this will become an open circuit. So may muna siyang negative, positive VI dira. You have the resistor. Since reverse bias man, open ra na imong circuit. So the output, unsa man imong output dira? Of course, kung imo na i-measure direct tester, you're basically just reading the value of your input. So, pasabot, ang output nimo is just the replication of your input. So, negative cycle man na. So, kung unsa itsura sa mong negative, sunon ra na sa imong output. Same is true with this. No? Gisuon na gyapon na yan. So, whatever, kung sinusoidal, ang imong output ano will be clip sa positive, suon sa negative. Okay, that's for parallel. Mag-introduce na po ta karon og bias na po class. Mag-add na po ta. Usually, actually all the time, when you say bias series or bias parallel, it's always gonna be in series with your diode. So, kaganina, ang bias nato na dire, tapad man siya sa diode. Karon imong diode ginaka-parallel naman na sa imong load, dire na po nato itapan ang ato ang supply. Okay. So during positive cycle in this, ato sa i-analyze ani siya. Hmm? Ang nahitabuan ni is during your positive cycle class, kung tanaw nimo with respect the diode with respect to your 4 volts diri nga supply, it is forward bias, right? Because this is positive and this is positive. Okay? However, sa imong input, because this is positive and this is negative, it is reverse bias. So, ang pangutana, kinsa magdaog ani nila? The answer is whoever or whichever is the higher potential, that will be the winner. Okay? So, tanawin nimo, ang imong input voltage manggod, moagi pa man na siya different values, 0, 1, 2, 3, 4, until kini nga specific input, until 16 nga maximum. Okay? So, during the time nga less than 4 siya, okay, butang na nato 1 ha. Kung 1 volt pa na siya class, what will happen? It will be forward bias. Nga naman, higher potential man ang 4 volts. So, ang imuhang diode, asa man siya mas muto, okay, bali. Okay. Mas dako man imuhang charge ani, it will be forward biased. Okay? During sa time nga 1 siya. Pag abot niya 2, forward bias yapon na siya because higher pa man imong 4. Okay? So, pag abot na karon niya 4 class, uy, kinsa na may daog ani. Okay? Actually, it will become same ra gyapon na siya og behavior, no? Naka-forward bias yapon pero pag mo saka na siya gamay 4.1, 4.2, what happens is ma-reverse bias na ni nga naman kini namang input ang higher potential. Okay? So ato lang tan-awon. During positive cycle, natay different condition here. First condition is that when your VI is still less than 4 volts class. Okay? Mo-on imuhang diode. Okay? Mo-on imong diode tungod kay naka-forward bias siya ani. So kung mo-on imong diode class, mahimo ni siyang closed circuit, right? Close. Okay? So pag closed circuit na siya, unsay basa karon sa imong voltage output? Of course, ang yarang girid nga voltage actually is ang 4 volts. Okay? Kay mo man na siya parallel ani. Kana siya. Okay? So during VI less than 4, diode is on, VO is 4 volts. Now, when VI is greater or equal to 4, higher potential naman ni siya imong input. So what happens is diode is off. Mo-open naman na siya class. So kung mo-open na siya, unsa may mahitabo kung naka-open gali ni, ang imong output, you're basically just measuring whatever imong value sa input. Okay, so VO will always be equal to VI. That's why kung tanaw na to class, kini siya nga values here, kini. These are the values of your input less than 4 volts. So what happens? Kini siya, kani siya nga value, input less than 4 volts, atong gi-measure dire, VO is equal to 4. That's why kini nga portion here, it's always gonna be 4. Kini sad. Okay. So, ato ta karon sa kini sad ato sa input sa gamay mo kani siya. Kini siya ang mga value mo yung less than 4. So, that's why kini nga value kani simo positive. 4 na siya. Okay? So, pag greater than 4 na daw siya class, okay? Kani ang mga values greater than 4 sa imuhang input, di ba? Unsa iyang giingon? Output voltage is equal to input. So, kung unsa itsura na iyarang gisuon. Sunon ra na nako. Okay, gisuon ra na. Okay. What happens now during your negative cycle? Muna ta sa positive cycle. During the negative cycle class, tanawa. During the negative cycle, your diode is forward bias gihapon no, with respect to your 4 volts because positive dire, positive sa anode. Sa imong V input, negative man na, negative man sa ni class. So, again, your diode with respect to your input voltage is still forward bias. Meaning, wala siya problema di ay. Wala siya other condition nga maabot siya ani nga certain value, ma-off siya or ma-on siya. Wala. During the whole negative cycle, it's always gonna be forward bias. Forward bias po siya with respect to your 4 volts. So, Meaning, during the whole cycle, the negative cycle, your diode is always conducting. So, always siya naka-close circuit. So, naka-close na, and the 4 volts will remain there. Okay, 4 na. So, unsa man karon ang atong voltage or output voltage is always gonna be 4 volts. Kani iyang always basahon. So, during the negative cycle, output is always equal to 4 volts. That's why, during ani nga negative cycle, for whatever value dira, always na siya 4. Okay, always 4 volts. That's why this is your graph. Okay, so let's go to, okay, muna po na siya atong simple parallel clippers, no? Ato naman i-discuss ganina, and then these are the different types po of bias parallel. Ang atong na-discuss ganina is kani. Okay, so that's why yung graph is in ani. So, depende gyapon na kung sinusoidal, then, syempre, sinusoidal po na yung mga output. So, kung lahi-lahi na to class, atong balihon ang ato ang voltage or atong diode baka atong balihon, it will have a different po nga itsura. Pero, makita ninyo nga nagyapon siya gi-clip nga part sa atong graph. Kaniyang gi-clip sa niya, gi-clip sa niya, and all this. Okay? So, that's the idea of your clipper circuits. Okay, let's go to clumper. Let's go to clumper class. So, nakalat may clumper. Okay, clumper is a different circuit in the sense that hindi siya clipper, of course. Okay, a clumper class is a network constructed. Ay, ga-share screen to ba ako? Wait lang, please. Intention. Ay, wala. Wait lang, class ha. Let me pause this world and then share screen. Okay. Hopefully, na-share na din ako. Makita ko na-share na. Okay, let's go to clumper. Clumper class is basically a network constructed of a diode, resistor, and a capacitor. So, mo ginay pinaka-main sa imuhang clumper na nakay gi-introduce karon nga capacitor. So, ang iyang purpose is different from clipper. Clipper is nag-clip siya og signal, pero your clumper is shifting the waveform. Imo siyang gi-shift. Okay? Pwede pa up, pwede pa down. Okay, mo lang na yung pag-shift. Okay? And then, ang yahang connection ani will be that your capacitor is connected directly from input to output with a resistive element. So, connected yung resistor, yung capacitor, yung resistor. And then, the diode will be parallel with the output signal. Pero it may or may not have a series DC supply as an added element. So, nagyapon tayo bias ng mga clamper. So, let's try to discuss. Pero I'll change the connection first sa kayo. Ugad ko. Papa naman mag-cut class sa video. So, okay. For a while lang, Jud. Oopsie. Okay. Gitas rin ako ang pen. Sige. So, let's have this clamper circuit. So, kung akong giingon. Wait lang ah. Sorry, I think nasa pa akong pag-emphasize ganun na class. Ang capacitor is not in series with the resistor. Capacitor is in series with the input. Okay? But the resistor will be parallel with the output signal. So, in ano yung ensure, you have a capacitor in series with your input, and then your diode is parallel sa mga output as well as your load nga sa resistor. Okay, so let's discuss the analysis first. How are we going to analyze a clumper circuit? First is, example ano yun niya, pero this is the theory. If we analyze the circuit class, we begin by examining the response of the portion of the input signal that will forward bias sa diode. So basically, tanaw nimo circuit, and then tanaw nimo kanus mag-forward bias imuhang diode with respect to your input signal. Is it during the positive cycle or is it during the negative cycle? Because whichever cycle class or portion of the input signal nga ma-forward bias ang diode, dito ta mag-start sa atong analysis. Okay? So now, example lang. Example, ma-forward bias imong diode during the positive cycle. So, dito ta mag-start, and then what are we gonna do next? Is that we assume the capacitor class will charge up instantaneously to a voltage level determined by the surrounding network. Meaning, atong i-maximum ang atong input during this portion of the input signal, say positive cycle. Okay? And then, atong KVL class, tanaw na to, unsa na karon ang voltage nga mo charge ang imong capacitor. After which, i-assume na po nato nga or analyze po ta during the next ni mga portion sa imong signal. So again, if lang nag-start ta og positive cycle, okay? And then sa step 2 makuha nato ang voltage sa capacitor until unsa nga voltage level siya mag-charge. Next nato is we analyze the circuit during the negative cycle. And in this case, we assume class that your VC is always going to be constant during this cycle. So, unsa iyang na-charge na, for example, naka 30 volts na siya. Mo na itong i-carry diri sa to ang next step. 30 volts kaya po siya. Okay? And then throughout the analysis, we maintain a continual awareness of the location and the defined polarity for V output. Basically, dili lang ang V output, tanang components class dapat aware ta unsa gid ang proper polarity kay kung masayop mangugaw analyze sa ani class, kung una sa imong input signal nga ma-forward bias imong diode, mabali ang imuhang polarity sa capacitor. So later yun yung masabtan. And then finally, step 5 is after ta mag graph sa atong output waveform, tanaw na itong total swing. When you say swing, this is your peak to peak nga or kung sa oscilloscope pa nakaana mo na sa class, no? Peak to peak nga measurement sa atong output. Dapat mo match siya sa atong input. So for example, imong peak to peak sinusoidal 20 volts niya to negative 20. So imong peak to peak ana will be 40, right? So ang imong clamper current class, it could be shifted no from man. It could be ana. It could be from 10 to negative 30. Ni shift ba? Ni ubos ni siya ang 20 to negative 20 ni. Pero tanawa class, ang iyang output swing or yung peak-to-peak na measurement is still 40. So kana lang ato ang tanawon. I-make sure na to that it matches. Sige, let's have an example. So, for example, katotong circuit kaya ganina. Ang atong diode class, step 1, kanusa mo forward bias ang atong diode, it is during the positive cycle. Okay, anode man na. And this is, di ba, dirang positive. So, during positive cycle, ni forward bias ang ato ang diode, dira na ta mag-start og analysis nato. So, during positive cycle, ato na i-assume dira ang positive cycle, what is now the voltage imong capacitor? So, kung nag-short ang imong diode dira, kay ideal man eh, during positive cycle, na forward bias na siya, nag-short na siya, narin tayo way to solve for, ato lang yung pangalan ng VC class, no? VC will be, kung mag-KVL ta na, negative V plus VC. This is very important. Ang imuhang polarity sa imuhang voltage sa capacitor will be positive sa imong left. Nga naman, actually, dali ra kasi duman kung positive ni positive po kadira. Kung negative na siya, negative po kadira. Pero in this case, nag-positive ka, tungod kay ang imong current, di ba kung anode ni class, ang imong current will be in that direction. It will be ID. So kung kanay imong direction sa ID, it will follow nga ang direction din sa imong current paana. Okay? And if ang direction nimo padulong dira, ang first nga polarity nga iyahang maagian for every component, di ba mo ng positive? Okay. So, dira man siya una niagi sa imong left, so dira mo positive sa capacitor. Or para mas dali lagi ninyo mahinumduman, kung positive imong VI dire, positive sila, magtapad sila. Okay, balik ta. Mag-KVL ta class, negative V plus VC is equal to 0. So, VC is equal to V. Okay? So, whatever din yung voltage ni mo dira, mo sa limang voltage sa capacitor. So, kay parallel naman sila. Okay. So, karon ni-charge up na siya up to V. Actually, kining V class is the maximum value sa imong input, no? So, ato siyang i-charge up to that value. And then, next na po na itong problem is we analyze during the other portion of the signal, which is the negative cycle. So during negative cycle, ma-retain ang imuhang VC dira, which is naanay mohang polarity dira always. And then your diode will be reverse bias man no. So naka-open ka dira. So tungod kay nag-hold na siya karon og voltage nga V. Pag KVL na to ani karon class, how are we going to get the output? Of course, it will be V plus V, mo yung voltage sa capacitor, plus V output is equal to 0. Okay? So V output now will be, tanawa, nahimo siyang 2V. So if you transpose it, nahimong negative 2V. So karon class atong i-graph. Sorry, ang output de ani class ato ang positive cycle tungod kay na short man ni. Okay, shorted man ni. Ang atong R will always be 0 po na iyahang voltage kay parallel naman sila sa diode, di ba? So your V output here will always be 0 during the positive cycle. So if I graph na to na class, this will be the result. Okay? So during positive cycle, 0 ang imuhang output. Okay, nak-0 siya. During the negative cycle, sa man to itong nakuha, negative 2V. So naa siya diri, negative 2V. Ga-square lang taha kay para mas dali na to makita niya ang value. So this is again the negative cycle. Mahimo siyang negative 2V. Pero i-check na to class ang total swing. The total swing of this is tungod kay V man ang height ana, kini V sad ang height ana. The total swing will be 2V, right? And sa tong output, same gyapon class. Ang total swing na to is 2V ra gyapon. So tanaw ni, kung tanaw na to class, mura ra gi-shift na to ni. Actually, dili gid mura gi-shift gid ni nato nga signal padulong sa ubos. Okay? So from here, mana na siya. Okay? Gi-shift na to padulong sa ubos. Ana. Mura na to ni gipaubos by V nga units. Paubos. Okay? So if you understand, sige, that's a specific example. Okay, natin input daw, square wave. Yeah, maximum of 10 dayon sa positive, no? Negative 20 sa negative. Sa negative cycle. Okay, so now, let's start to draw some, okay. So, again, step 1 is, kanusa man nga cycle, ma-forward bias ang imong diode. So this is positive, this is negative. Therefore, during negative cycle, di ay siya ma-forward bias. So, we will start our analysis during the negative cycle. So, mao nang nakay negative cycle dira. So, ato, again, i-maximum na nato. During the negative cycle, atong maximum value is negative 20. So, negative 20 na to siya diretso class. So, muna akong giingon, kung negative 20 man good, and negative cycle, ang dagan sa imong kuryente kay paana no tungod kay nadirang anode. Okay, so kung nadirang padulong nga kuryente, padulong po na siya paana class. Okay, so kung pa-left na imuhang current, your positive will be here, nasa right side sa imong capacitor. Or you could just say nga gatapad imuhang negative. Okay, so kabulo natin sa polarity sa capacitor. Okay, because of the negative cycle, mauna imong polarity sa capacitor. So, naka-on man na imong diode no, so naka-close circuit siya. Therefore, we can analyze the value of our VC. So, kung mag-KVL tayo class, we apply KVL, that will be 20 minus VC plus 5. Okay, kinatay consider. Para makuha na to ato ang VC. So, VC is just equal to 0. So, VC simply is equal to 25 volts. Diba class? 20 plus 5 niya, transpose. So, therefore, ayang ma-hold nga voltage is up to 25 volts. Kanya, unsa gito tong assumption? For the next cycle, which is katong positive cycle na ta, nga ang maximum sa positive cycle is 10. Okay, morning git 10 nato na siya dira. Atong next assumption is that we assume that the capacitor holds this value, which is 25 volts. Nag-hold na niya nga value. So, 25 na siya. And what happens to our diode? During positive cycle, naka-reverse bias man tano. So, naka-open na to ang diode. Okay. So, if we apply KVL there, that would be negative 10 plus, minus 25 plus output voltage is equal to 0. So kung i-transpose nato na tanan ng -10, -25, we have output voltage of 35 volts. Sorry, wala di ko kakog output voltage diri. For during the negative cycle, imong output voltage is unsa man, that is parallel to your resistor, parallel to this branch here. So that is 5 volts. Simply 5 volts, no? So during negative cycle is always gonna be 5 volts. Okay, 5 volts imong input sa negative and then 35 sa imong positive. So if we graph that class, ingani siya. During positive, ato lang ni disregard sa inato kay nagsugod man natong analysis sa negative cycle. So diri man tagasugod. During negative cycle sa to positive 5. So mo na nakay positive 5 dira. Then during sa atong um, positive cycle atong nakuha nga voltage output is 35. So mo nang 35. Okay? So if you graph that, ingani ang itsura. And checking the output swing from 10 to -20, that is 30. And from 5 to 35. From 5 to 35 class, that is still 30. So they have the same total swing. So our solution is correct. So again, tanaw lang ninyo class, mura ra nato ni gi-shift pasaka ang ato ang graph. No? Gisaka ra gid nato siya. Okay, same ra man na siya og itsura. Okay? Kana po siya, negative to positive. Ana. Okay, so that would be all for the biased nga clumper, no? So there are different kinds of biased clumpers. Again, kung bali-balihon nimo dira ang imo ang bias voltage nga gibutang in series with your diode, nya kung balihon sa nimo ang diode, then you will have different itsura sa imong clumper. Pero it's still the concept still holds, no, that you're shifting the waveform without changing the output swing of the input signal. Okay, so that would be all for the clumper, and I will leave you with this exercise so you can check, and who knows, this might come out in the exam. So we have a sinusoidal input here, and then this is your output waveform for this particular clumper network. Okay, so that would be all for clippers and clumpers, and please finish your PIT and then study for the exam. This is the last topic for midterm. Okay, okay, so that would be all. Thank you very much.